This demo makes use of a bunch of new features in CockroachDB. Vectors, which were introduced in 24.2, triggers, which were introduced in 24.3, common table expressions or CTEs in functions, which were introduced in 25.1, and vector indexes, which will be introduced in 25.2 by the time this video comes out. And what I'll be demoing today is a very basic and contrived trading application whereby I'll use vectors to highlight anomalous trading activity. I'll use CockroachDB version 25.2, and when you see me using CockroachDev, that's just my local build of CockroachDB. By the time it comes out, this will just be Cockroach for you because 25.2 will already be available. With my cluster up and running, I'll enable vector indexes and I'll create some tables. I'll have a table to store trader information, a table to store counterparty information, a table to store the securities that we'll be trading, 2 enums, 1 action, which tells us if the trade is a buy or sell, and 1 unit that represents the type of quantity, ounces, tons, or kilograms. And finally, a table to store trades. Note that we have a vector column here with 7 dimensions, and we have a vector index over it. Now, rather than us having to calculate the vector at the point of insert, I'll now create a trigger and function pair to automatically calculate the vector information and insert it into the table whenever a new row is inserted. This will be a before insert trigger. First, the vectorized trade before insert function that returns a trigger. And into this vector, we'll have an action dimension, buy or sell, a unit vector, tons, kilograms, or ounces, a quantity dimension, the price per unit dimension, and the timestamp dimension. All of this information I'll use to determine whether a trade is anomalous. And finally, the before insert trigger. For every row in an insert batch, I'll execute the vectorized trade before insert function, and that will ensure that the vector is also populated. I'll insert some test data. And if we look at the trade now, we'll see that the vector has also been populated, and that would have been through our trigger and function. If we take a look at an explain for the insert, we'll see that the vectorized trade before insert is being used. So too is the vector index on the trade table. Now I'll insert a bunch of random data to simulate what regular trades look like. And selecting a range of distinct data from the table shows that our vectors are being populated for all the different combinations of trades. Now I'll write a function that returns anomalous trades. I call it anomalies. It takes a limit of rows to return, by default that's 10, and it returns a table. Now this will calculate an L2 distance and a standard deviation distance and return the top 10 anomalous values, the rows that have the greatest distance from the average trade. And if I run that, we'll see that because we don't have any anomalous trades in the table at the moment, there are no high L2 distances, and we don't have a crazy standard deviation either. Let's change that now by inserting some anomalous trades. First, I'll insert an anomalous quantity. So we're buying 10,000 kilograms of something. And next, we'll buy 500 kilograms of something, but with an anomalous price per unit. Searching for our anomalies again, we now see the 2 anomalous trades that we just entered have a much higher L2 distance and a much greater standard deviation from the rest of the trades. We can also join to that function to return the specific information that we're looking for. And as expected, our 2 anomalous trades appear at the top with their anomalous quantities and price per units. As said before, this is a very basic and contrived example. There's a single price scale for all securities, and there's no logical grouping between trades. I'm taking the average of all trades. But it does show what's possible. I'm using functions to hydrate vector data, which reduces the complexity on applications. And I'm also able to return, with low latency thanks to my indexing, anomalous trades based on my entire trade history. This video falls into the AI and ML video series, among which we've already recorded a video on RAG, Retrieval Augmented Generation, a recommendations engine, and now anomaly detection. Next, we'll create a video on cheat detection in gaming that all shows what's possible in CockroachDB.